aircraft positioning and monitoring. The navigation system constantly checks and selects the best mode to use, based on the estimation of accuracy and the integrity. The GNSS, inertial, GPIRS, is the main navigation mode, used as long as GNSS data are available. The GNSS, inertial position is continuously calibrated by a filter that uses the inertial data from IRS and the GNSS data from multi-mode receiver. The filter's characteristics can differ between the different navigation system, flight management system or air data and inertial reference system suppliers. The air data and inertial reference system ensures the continuity of the provision of the aircraft position. If the GNSS is lost, the GPS primary status will remain for a certain time due to the extrapolation function in the FMS or air data and inertial reference system. When GNSS, inertial, GPIRS, data is not available, or does not comply with the accuracy and integrity limits, then the FMS automatically reverts to one of the other modes, based on the sensor availability and the estimated position errors. Accuracy and integrity limits PBN operations associate a RNP value to the different legs of the procedure. This RNP value must be set in the aircraft navigation system to define the accuracy and integrity limits. These limits enable to monitor the aircraft position and trigger messages in the cockpit, monitoring of GNSS availability. For PBN operations that use a GNSS-based position, the operational regulations may require the operator to determine the availability of the GNSS-based position before departure. The operator can check the satellite constellation availability using NOTAM or appropriate websites, for example NANUS from U.S. Coast Guards. A ground-based prediction program, GBPP, could be used to assess GNSS availability in following cases. GNSS availability demonstration is not declared in the AFM, or, less than 24 satellites are available, or, potential masking of GNSS signal in some mountainous areas, for RNP procedures only, or, low RNP values, for RNP are below 0.2 nautical miles only. Monitoring of other navigation modes, navigation accuracy, high, low. When GPS primary is lost, the navigation system will automatically revert to another navigation mode. The navigation system may revert to NavAids, inertial or to inertial only mode when no NavAids can be used for the aircraft positioning computation. For each navigation mode, the FMS provides the estimated position uncertainty, also referred to as estimated position error, that can be compared to the navigation accuracy. The best navigation mode is selected on the basis of the comparison of the APU of each navigation mode. As illustrated on figure, the APU is continuously compared with the required accuracy to provide an appropriate alerting, in the case of an accuracy loss. When the APU is higher than the required accuracy, the navigation accuracy switches to low, and the Navicar downgraded message is displayed on MCDU, MFD scratchpad and on the ND. When the APU is lower than the required accuracy, the navigation accuracy reverts to high, and the Navicar upgraded message is displayed on MCDU, MFD scratchpad on the bottom of the ND. The navigation accuracy may be used in degraded conditions to support flight crew decisions. As a summary, figure illustrates an aircraft in the GNSS, inertial navigation mode facing a total loss of GNSS position. When the GNSS position is lost, the following events occur. An extrapolation of the aircraft position is performed. If the integrity criteria is not met, the GPS primary lost message appears. Then, the aircraft position used by FMS is only based on inertial data. If the position accuracy diverges and exceeds 1 RNP, the Navicar downgrade message appears. As a result, GPS primary function monitors the position integrity of GNSS, inertial navigation mode. Nav accuracy function monitors the position accuracy of the NavAids, inertial and inertial only navigation modes. RNP operations rely on position integrity monitoring. Therefore RNP operations can only be performed when the aircraft is in the GNSS, inertial navigation mode. Flight Guidance Modes. Aircraft navigation system provides flight guidance modes to enable flight crew to efficiently follow the PBN procedures. This part describes the different aircraft flight guidance functions, and which one to use during PBN operations. Nav mode. The guidance in nav mode ensures that the aircraft lateral deviation converges with the intended flight path, that is cross-track equals 0, as requested by the PBN operations. Therefore the nav mode is widely used for PBN operations except in approach mode. The guidance modes used for PBN operations during the approach phase, RNP approach, and RNP-AR, are described in the following sections. XLS. The X-landing system, XLS, concept, which provides a common ILS lookalike HMI for straight-in approaches. As part of XLS concept, the following sections describe the FLS and SLS functions. FLS. The FMS landing system, FLS, provides an ILS lookalike HMI with vertical and lateral guidance for non-precision approaches, NPA. As described in the figure, the multi-mode receiver computes both of the following: a virtual beam from the runway threshold provided by FMS and DB, associated lateral and vertical deviations based on the aircraft GNSS position compared to the track and slope components stored in the FMS and DB. The guidance laws are the same as those for an ILS approach, with a pseudo-localizer referred to as F, localizer, and a pseudo-glide referred to as F, glide, slope. The FLS vertical beam relies on the barometric reference. FLS can be used on RNP approach operations. The F approach capability on PFD is required for operations of RNP approach will nav all nav, VNAV minima. RNP approach operations cannot be performed with F approach plus RAW or RAW only. The RAW mode relies on NavAIDS data instead of GNSS data.